Hi, I'm Soumya, and I'm here to present our work on differentiable mixing style transfer done in collaboration with our colleagues at Center for Digital Music and Steinberg. Mixing is basically a process within the pipeline of audio production, and it involves blending of multi-track recordings. It involves a lot of technical as well as creative decisions that are taken and achieved using audio effects. We found that engineers want controllable and context-aware assistive mixing systems, and one way to provide this context is using reference songs. So we introduced Diff MST, which basically takes in input tracks as well as a stereo reference song and predicts mixing console parameters, which are then used to get the predicted mix. So basic architecture of Diff MST consists of a spectrogram encoder, which captures information from the tracks as well as the reference song, and there is a transformer controller in which the transformer encoder does the style transfer aspect of it, and a MLP which predicts the control parameters, and finally we have a differentiable mixing console which generates the predicted mix. The mixing console basically consists of a channel strip on each of the tracks and then finally a master bus, and this is all implemented in DASP, so it's basically differentiable end to end. We use two losses. One is multi-resolution SDFT, the popular one, as well as the AF loss, which basically is a mean square error between ISMIR features specific to dynamics, spatialization, and spectral properties of a mix. And in terms of dataset, we work with multi-tracks from MetaDB and mixing secrets, as well as reference songs from MTG Jamendo. We train our model using two different methods. One is an extension of DPAFX to multi-track scenario, where we create a random mix and use one section as the ground truth and the other one as the reference. We see poor performance with this kind of training method because the model sees a lot of random mixes which are generally bad sounding and a lot of diversity. In the second method, we use unpaired reference songs and input tracks. Reference songs are from Jamendo and input tracks from MetaDB and Cambridge, and then we compute loss between them, which is unreferenced loss function. And we see that the performance definitely improves. We compare against baselines of equal loudness mix, human mixes, and a black box approach to style transfer. And we find that our model AF16 performs the best, which is trained on AF loss on 16 tracks. And we see improved performance with training on more tracks, training on real world examples, and as well as using AF loss. And so our model basically is controllable, context aware, as well as interpretable. In terms of limitations, we fail to do subjective evaluation because of lack of time. There's no automation, no reverb module, as well as during inference we observe performance deterioration when using longer lengths of sections with the encoder, as well as when tracks are inferred on more tracks than the model was trained for. Finally, thank you very much for being here. Come check out our LBD where we present Diff MST integrated in Cubase and audio examples here.